everybody. I am Miss List, and we are back here with 3.9, which is on separation techniques. And this includes a area of chemistry called chromatography. So chromatography provides a method of separating mixtures of solutions based on polarity differences. There are three types of chromatography that we focus on in AP Chem, and they are paper chromatography, thin layer chromatography, and column chromatography. The reason this shows up in Unit 3 is because it has to do with our friend intermolecular forces. So in paper chromatography, which is our first one that we're looking at here, essentially a line is drawn in pencil near the end of a strip of filter paper, and a drop of the sample that we want to separate is placed on that line. And then the paper is placed in a shallow layer of solvent where the bottom of the paper is touching the solvent, but the line is not. And what happens is, so this is what it would look like at the beginning, this one. What happens is capillary action draws the water up this way. And depending on the polarity of what is included in the mixture, if it is polar, it will move with the water. If it is nonpolar, it will stay put. So as the solvent flows upward, how much each dot moves depends on if it has a similar polarity to water or a different polarity to water, or whatever the solvent is. I said that water is our solvent. You can also use nonpolar solvents. You can also use polar like water, or you can use a mixture between the two. And that will change how the dots separate. So the stationary phase is the paper. That's what we call the paper. And the mobile phase is whatever the solvent's made out of. So to analyze a paper chromatography, we do what's called an RF value. And essentially, it's a ratio that looks at the distance traveled by the solute divided by the distance traveled by the solvent. So we take a ruler and we measure how far the dot went. So this would be my numerator, is how far my dot moved, and then how far the solvent moved. And so that would be my denominator. Now, usually when we do paper chromatography, we're using it as a comparison technique. So I would compare RF values between a known compound and what I got. We're not comparing distances. The more similar in polarity the sample is to the solvent, the further it will travel. And again, this is a comparison technique. So usually, let me get my eraser here, we would have what's called a known sample. And let's say my known sample just moved to here. Well, by comparison, if this was my unknown and it didn't move what I thought it was going to move compared to my known, so I can eliminate that as a possibility. And so this is always used as a comparison technique. You're comparing it to what we call a known standard. Next is our thin layer chromatography. Thin layer chromatography is very similar to paper chromatography, except instead of filter paper, a thin layer of silica or alumina, which both are extremely polar, is coated on a piece of plastic, and that's what we use as our stationary phase. More polar compounds will stick to the TLC plate and travel shorter distances, while nonpolar substances will diffuse into the solvent and travel further. UV light can be helped to separate samples that are not colored to the naked eye. And this method is frequently used for identifying amino acids. So over here on the right, we have an example where we can't really see any dots like we could in the first example. But when we put it under UV light, we can see what we have going on here. And so you might remember we compared So the first dot would be our mixture. And so my mixture must contain whatever this blue one is because it has a dot that matches with the blue one. It also must contain triangle, and it would contain whatever this bottom one is. This one does not appear to have a dot. If I did, it would match up with that spot as far as the RF value, and I don't see anything there. So again, I have to stress that this is a comparison technique. We're always going to be comparing to known values or known standards. Thin layer chromatography is used a lot in organic chemistry. So if you go on to college and take Chem, you're going to be doing some TLC plates to look at different compounds. Next is column chromatography. Column chromatography is essentially very similar to the other separation techniques that we've used, except with TLC and paper chromatography, we're trying to figure out what is in the substance, not necessarily to separate them, because we're comparing it to a list of known values. With column chromatography, though, you can actually separate the substances. So the idea is that we would place a little bit of steel wool at the bottom of a burette. So there's steel wool in here that's not really drawn. It doesn't necessarily have to be a burette. It can be different, just a glass tube that has an opening at the bottom or something similar. It is filled with silica or alumina gel, which we know are really polar. A mixture is placed at the top, and notice that we'll call it picture number 1, our mixture is purple. And as gravity goes to work on our column, in picture 2, we start to see more colors come out, 3, and then by 4, we actually have 2 different bands, a red band and a blue band. So if I was to put my beaker underneath, I could catch the red as it came off the burette. And then once all the red stopped coming off, then I could put my beaker underneath and catch all the blue. So the idea is that we are flushing with a non-polar solvent. So usually whichever one is non-polar is going to come out quicker. So if I was comparing these two guys, a non-polar one, or less polar, I should say, would be the red one because it comes out first. It goes with the solvent. And the one that is more polar is going to get stuck in the column and take a little bit longer to come through. Another method of physically separating mixtures is called distillation. Distillation is actually separating compounds based on boiling point and intermolecular forces. So intermolecular forces can affect boiling point. Things that are polar tend to have higher boiling points. So here in my flask, I'm coloring it with blue, is a mixture, and I have a hot oil bath. And what I'm going to do is I'm going to start heating that mixture, but I'm not letting it boil. And so if I heat the mixture to a certain temperature, I can get maybe one of the components to start changing into gas phase. And if one component starts changing into gas phase, it will follow this tube where it hits what's called the condenser. And the condenser essentially is pumping cold water into this tube, and it cools the gas and back into a liquid, and then it will end up as a liquid back on this side. And so if they have 2 different boiling points, one thing would be changing into gas phase at the lower temperature, that would be our non-polar, or less polar, would have a lower boiling point and it would get transferred over, and the thing that had the higher boiling point or is more polar stays put. So let's look at an example. Consider the paper chromatography experiment shown below. A student is trying to separate a mixture of components of X and Y. The paper is slightly polar. So they're asking us, what is the mobile phase in this? And remember, the mobile phase is whatever our solvent is. And so our solvent, it tells us, is hexane. What is the stationary phase? Our stationary phase is going to be the filter paper. And it says that it's slightly polar. So I'm going to say slightly polar stationary phase, or slightly polar filter paper. Now here's where the analysis comes in. It says, is component Y or component X more polar or less polar? And remember, when they mention both, we have to talk about both. So if my mobile phase is hexane, hexane is nonpolar. So the one that is going to travel with hexane should have a similar polarity. So if I was going to identify this, I would say that this one is most likely nonpolar or less polar because it moved the furthest in a nonpolar solvent. And I would say that component Y is more polar. And the reason would be because it didn't move as much, which means that it was attracted to the filter paper. And they did tell us that the filter paper was slightly polar. All right, that is it for chromatography. More than likely, you'll be doing some labs that involve chromatography with your class. So I hope that that drives in the point. Again, this is just an application of IMFs, and it's a way for us to identify and or separate mixtures. All right, I hope you have a great day.